Now, Williamson synthesis method. Alexander William was a professor in a University College of London. He has discovered this method, so this method is known as a Williamson synthesis for the manufacturing of ether. By using this method, one can prepare, by using a Williamson synthesis, one can prepare symmetric as well as asymmetric ether. So one can prepare symmetric as well as asymmetric ether by using this method. In this method, alkyl halide is allowed to react with a sodium alkoxide. Suppose as alkyl halide I have taken a R-X. Now this alkyl halide we have taken and it allowed to react with a sodium alkoxide. So as a result, here substitution reaction occurs, oxygen will attack on this carbon and we get this byproduct sodium halide and we get main product ether will be obtained. So here one can prepare symmetric as well as asymmetric ether. But this substitution reaction is better with a primary alkyl halide. Suppose I want to prepare, by using this one can prepare secondary also or tertiary ether also can be prepared. Now here sodium alkoxide of tertiary butyl is allowed to react with a methyl bromide. Then here elimination reaction occurs, substitution reaction occurs with a SN2 mechanism. Here this oxygen having a non-bonding electron pair, it will attack on this carbon. This is sodium have a positive charge, bromide ion having a partial negative charge. So here oxygen joined with this methyl group, sodium joined with a bromine and it removed in the form of sodium bromide. And we get this type of product CH3, CCH3, here CH3 and here oxygen and CH3. So name of this structure we can give methyl tertiary butyl ether. We can write name of this structure methyl, then tertiary butyl or tertiary butyl methyl ether. So this reaction, the importance is this reaction that alkyl halide, primary alkyl halide we have to use. Suppose secondary halide is used or tertiary halide is used, then product will be alkene. Instead of substitution reaction, elimination reaction occur. Suppose I have taken this type of halide. Suppose this type of halide is taken by us. This is a tertiary halide is taken and reaction occur with a sodium methoxide. Will this reaction occur? Then reaction occurring in totally different way. Here this is a tertiary halide, or name of this tertiary halide we can write 2-methyl or 2-bromo 2-methyl propane. We can write 2-bromo 2-methyl and name of this structure is propane. So now here this oxygen will attack on this carbon, this bromine having a negative charge, sodium having a positive charge partially, so it removes in the form of NaBr. It removes in the form of NaBr, but at the same time, here carbon, hydrogen, carbocation, here tertiary carbocation will be obtained. Now stability of tertiary carbocation is maximum. So here elimination reaction occur. This oxygen take hydrogen from this carbon atom. This oxygen take hydrogen from carbon atom and as a result we get this product CH3C, here also CH3 and here double bond CH2. Bromine joined with sodium removed in the form of sodium bromide. Oxygen, here sodium methoxide will act as a base and this oxygen take hydrogen from this any carbon and remove in the form of CH2 and as a result carbon-carbon double bond form and we get this structure, it is 2-methyl propene. So here 2-methyl propene is obtained. It means whenever we have taken tertiary halide, then we get product alkene. So instead of substitution reaction, elimination reaction occurs. तो हमें जब भी ईथर बनाना है तो हमें प्राइमरी अल्काइल हैलाइड की रिएक्शन सोडियम अल्कोक्साइड से करेंगे. So by using this method one can prepare, by using this Williamson synthesis one can prepare an aromatic ether also. We have to take a phenol. Now phenol is allowed to react with aqueous solution of sodium hydroxide. So when phenol reacting with this sodium hydroxide, the reaction occur in this way: Na plus OH minus, here H plus and oxygen minus. It eliminates in the form of water, and as a result we get a sodium phenoxide. So here we get this sodium phenoxide. So phenol on reaction with sodium hydroxide, it gives us sodium phenoxide. Now whatever sodium phenoxide obtained to us, it allowed to react with a primary alkyl halide. Suppose it allowed to react with a methyl iodide. Then reaction occur in this way: Na plus combine and remove in the form of sodium iodide, and oxygen joined with this methyl group. So as a result we get this structure benzene ring OCH3. This structure IUPAC name is methoxybenzene. So हमें methoxybenzene मिलता है, and common name of this methoxybenzene structure is known as a anisole. Similarly, suppose it allowed to react with ethyl iodide. इसकी reactions ethyl iodide से होती है. Then same as reaction occur, sodium combined with iodine remove in the form of sodium iodide, and oxygen attack on a carbon. Oxygen attack on carbon, so we get this structure benzene ring OCH2 CH3. So this much part is known as a ethoxy. So this structure is known as a ethoxybenzene. And ethoxybenzene has a common name. It is also known as a phenol. So this phenol or anisole can be prepared from a phenol in a two-step. First step, phenol to sodium phenoxide, and sodium phenoxide to reaction with methyl iodide gives anisole, or reaction with ethyl iodide it gives a phenol. Other common name also for this ether, ethyl phenyl ether. This structure is also known as a ethyl, then after phenyl, ethyl phenyl ether. So by using this method one can prepare, by using this Williamson synthesis method one can prepare aliphatic as well as aromatic ether compound. But condition is that sodium alkoxide should react with a primary alkyl halide. With tertiary alkyl halide it gives alkene product.